What's up, guys? Welcome to question 5. Let's have a look at this one. Question 5.1 it's a trigonometry question. It says here, simplify the following expression without the use of the calculator. So in this case, guys, you need to be able to remember this one from your Cartesian plane. You need to be able to remember that this is a cast where tan is positive here, cos is positive, all of them they are positive here, sine is positive here. And the other thing that you need to remember, this quadrant is 180 plus x, this one is 180 minus x, this one it's negative x, this one is also 360 minus x. There's many others, guys, and then this one here it's a 90, sorry about that, 90 minus x. This one is 90 plus x, right? Okay, and then once you can be able to remember all this, guys, you need to remember this by heart. So now what you can do is that when you simplify this, the only thing you need to do, you just have to say, is tan positive or negative, where it's minus x. When you come here, it's cos that is positive, so therefore it means tan will be negative. So therefore your answer will be negative tan x, right? I'll try to be as slow as possible because I got a comment saying that I'm moving a little bit fast. And then here you've got 90 plus all you have to know that everything that has 90 on it is going to change. So first thing first, let's change this to cos x, right? So now what do we do when it's 90 plus? It's sine positive or negative, here is positive, so therefore this will just be a positive cos. So everything that involves a 90 plus or 90 minus on it, if it's sine, it will change to cos. If it's cos, it will change to sine. Please remember this, guys. But there is one that is negative, so you guys please make sure that you do revise this as well. We do have a video on trigonometry that explains this in detail. Right now here I'm just reminding you guys on how to deal with it. Okay, so if you have a look at here, we have got an identity there. So this one, if you check on your formula, it's as good as sine x and cos x. You need to write it like this, and therefore at the bottom here you have got 360 plus. All right, so 360 plus happens on which quadrant? 360 plus is on the first quadrant. The 360 plus is here, guys. 360 plus is here where everything is positive, so therefore this will be positive cos x. All right, with that said, now we can easily simplify this tan. It can be written as sine x over cos x. Therefore here you've got cos x here, and then plus here what you can do, cos and cos can cancel out, 2 and 2 would cancel out, then you are left with sine x only. Therefore here when you simplify, you're gonna say cos and cos would cancel out, you are left with minus sine. So this is what we are left with. We are left with minus sine x plus sine x. Therefore our answer will definitely be 0. All right, simple, straightforward. But the thing that you need to remember and put in your head, guys, please don't forget this, that is here. All right, okay, let's move on to 3.2. 3.2 says, given that sine 27 is equal to p, determine without the use of a calculator each of the following in terms of p. So the most critical thing here you need to take note, or that is a trick in this case, it's that this p is over 1. So what do you need to know? You need to know that sine 27 is given by p over 1, even though they don't write a 1 there. So what do you do? So this is, it's what sine is, what is opposite over hypotenuse. Right, so you are going to need a diagram to be able to deal with this one. Right, so now let's go ahead and draw our diagram so that we are able to see what we are looking at in this case. Right, So now let's come here, drawing a diagram here. They didn't tell us where it is, so therefore we'll just assume that it's in the first quadrant thereof. If they don't say anything, sometimes they'll give limits here. They will say it's at where our angle where 27 is greater or less. They will give us, say it's between 90 or 360. Yeah, they can give you a limit, guys, or they will say between 0 and 180. So if they do this, you must check for which quadrant it is. But we're still gonna do my examples on this one, where if something different comes up, I will show you. So therefore this is 27 here. So it says here opposite. What is opposite? This one is going to be p over hypotenuse, which is 1. X, we don't know what it is, so we must go ahead and look for it. So what can we use? We are going to apply Pythagoras theorem, which states that x squared plus y squared is equals to r squared. So therefore, what are we looking for? We're looking for x r squared minus y squared. So therefore, what is r is 1 squared minus p squared. Therefore we are gonna take a square root of that. Therefore that is going to be our x. Okay, so therefore our x will just be 1 minus p squared. Okay, therefore having that, so we can now go ahead and solve our equation. Please make sure, guys, that you really pay attention to what you're doing to avoid making careless mistakes. So 5.2.1. all right, what do we have? We have got cos 27. Cos is given by what? Is given by adjacent over hypotenuse. We already have the x here, which is square root of 1p squared. So therefore adjacent is just going to be square root of 1 minus p squared over 1. Okay, and that will be the answer for cos 27. Okay, let's move on to 5.2.2. is given by sine squared 63. Okay, so this one, what we need to do here, we need to simplify a little bit. This sine can also be written as, remember the co-function and the double, you can also write this as 90 minus 27, right? So in this quadrant of 90 minus, everything is positive, so therefore it means this will change to cos squared 27, right? We already know what is cos squared, so therefore we can easily substitute here. Is going to be square root of 1 minus p squared all over 1. Everything needs to be squared here, guys, so therefore our answer will just be that. 5.2.3 can be written as what are they looking for? They are looking at cos 13.5. So cos 13.5, we can also rewrite it, because now we don't have 13.5 here. I'm sorry, I said 3.5 there. We don't have 13.5. So what we can do in this case, we can write it as cos 2 times 13.5. all right, so therefore once we write it like this, we can therefore say this will be equals to cos 27 in this case. All right, so therefore what we can do in this case, cos 27, we know what it is, so I'm just going to write it here. But this part here, guys, this part here, very critical for you to get it right. Excuse me, this part here, very critical for you to get it right. What we can do here, we can therefore change this using double angles. So you can write it as cos squared, therefore 13.5. These things are basically equal to each other. We haven't done anything, we haven't added anything here. So let's change this now to cos 27. We know that is equals to square root of 1 minus 8 squared equal to 2 minus 1. I forgot a minus 1 here. Minus 1, 2 cos squared minus 1. And then therefore in this case we need to simplify and look for cos, because the question asks us to find this here. All right, so therefore we're going to take 1 to the other side. Simple algebra plus 1 2 cos squared, and therefore divide by 2, cancel out 2, and then now we need to take the square root of the whole thing. I'm just gonna move it here because I'm running out of space there. So therefore what you have now, we have got square root of 1 minus p squared plus 1 all over 2. Then we take the square root again, therefore we are going to be left with cos. Okay, now this is getting a bit messy. Okay, I forgot to write also here 1.3. Even here I didn't write 13.5 here. So therefore our cos 13.5 will be looking like that. Okay, and this should be our answer here, guys. Let me know what you think, and also if I made a mistake here. All right, so looking quite good. Let's move on to 5.3. 5.3, if cos x plus sine x is equals to k, express the following in terms of k. I think this is simple, straightforward, guys. Double angles. So what we have to do, we are gonna come here and expand this. So this will give us cos x, and then also multiply by cos 45 as well, and then it's going to give us plus sine x times sine 45. Okay, so therefore when you simplify this, it is going to be 1 over square root of 2 cos x plus 1 over square root of 2 sine x. Therefore we'll take out 1 over square root of 2 as our common factor to simplify this. Therefore in brackets we're going to have cos x plus sine x, and then therefore cos x sine x, they said is k. So therefore the only thing we need to do here is to substitute k here, and then therefore that should be our final answer. Let's look at 5.4. 5.4 is an identity, so we are going to take it from the left hand side. In this case they are asking us to prove that the left hand side is equal to the right hand side. So if you have a look at here, you've got an identity there, we also have an identity here, and also this one. So these are the things that we need to change. So let's go ahead and do that. Cos 2 theta, we can change it to, go to your formula sheet, guys. You will see how you are going to change this one. It's going to be 1 minus 2 sine squared theta. Okay, then we have got a plus 1 there, all over here at the bottom. You can change this one to 2 sine theta cos theta, plus then tan we can change it to sine theta all over cos theta. So therefore with that said, let's add them up here. 1 plus 1 is going to give us 2 minus 2 sine squared theta, right, all over 2 sine theta cos theta, plus therefore sine theta all over cos theta. So therefore in this case now we can need to find what? LCD, lowest common denominator. Because why? Because we have got a fraction. So now what you do, lowest common denominator refers to everything that is at the bottom. So sine and sine, and then we're going to have cos. All right, so therefore 2 sine theta cos theta goes how many times here? It's like they're canceling each other out. So it's like this one here cancels this one, you are left with 1. That one multiplied by the numerator will stay as it is. Right, so therefore in this one, cos goes how many cos? Cos goes cos here. So what is left out? So here's the numerator here. What is left out is 2 sine theta at the LCD. You need to multiply it with the numerator. I'm going to repeat that again, guys. I said cos goes cos here. You are left with 2 sine theta, which is this one here, and then you need to multiply it with the numerator. All right, so let's move right along. So you can see here, simplify. Let's simplify our numerator there. The denominator will remain the same. The denominator will remain the same. 2 sine squared theta plus, when you multiply with that one, you're going to have 2 sine squared theta. So 2 sine squared theta, if we simplify the top, we've got a negative here, we've got a positive there, so therefore this will minus each other out. So at the top we are left with 2 all over 2 all over sine theta times cos theta. Then we can take out 2 here and a 2 there, so we are going to be left with sine 1 over sine theta cos theta, which is also equals to the right hand side. You know, guys, with identities, I think you must scoop all the marks here. Fairly simple and straightforward. You shouldn't be confused with anything. If you have a question, please leave them on the comment section below. I am Gaston Mapala. Now let's move to 5.5. All right, 5.5 is a general solution question, the same way you would do if you were solving for x. So I've seen a lot of learners getting confused with questions like this, but please, guys, take it easy, fully understand, apply the basics. You shouldn't have any problem. So let's look at this one. We are given 4 sine squared theta is equals to cos 90 minus 2 theta. What you know about this one, whenever there's a 90 involved, the sign here, the cos or our aspect ratio needs to change. So therefore what you're going to have 4 sine squared theta. Here, when this one changes, is going to be sine 2 theta. So that's what it would become. So in this case now, guys, what would you do? You remember you are solving for theta, so we are going to take this sine 2 to that side. So what we're going to have 4 here. We're going to have 4 sine squared theta minus sine 2 theta is equal to 0. So therefore in this case now, that's what we have. So therefore we're going to have 4 here. We need to change this one, guys, because now it looks like it's an identity. This one we need to change it to make our life easy. So not equal sign there. So this one will be negative. It's going to be 2 sine theta times cos theta is equal to 0. So if you have a look at this one, remember now, guys, this is the same as solving for x. I know most of you guys are thinking, okay, but this, how am I going to solve for theta here? I'm about to show you now what you can do in this case. I'm going to use a different color to illustrate what I'm saying. If I were to say to you factorize this, you're going to say, but how? But if I were to write the same thing, I said 4x squared, okay, let this one be x, this one be x, and then let this one be y, cos is equals to y, minus 2x times y. Can you see, guys, that if I were to say this, if I were to say to you this, you are going to take out a common factor of 2x. Okay, you will remove a common factor of 2. Remove a common factor of 2x. Then here you are going to be left with 2x minus y. Therefore, you are done solving for x. Can you see, guys? So let's apply the same thing, but now the only difference here is that now we are using cos and sine. Don't get confused, please, guys. All right, so now let's continue applying the same rule here. What are we saying? We are saying, okay, let's take out a common factor of 2 sine theta, and we're gonna do exactly that. We're gonna be left with 2 sine theta minus y, no, sorry, minus cos. Now I'm saying minus y, minus cos theta is equals to 0. So, and that's how you would deal with this one. Just applying simple basics, guys, you can already see. So now what do you have? If this was, you're going to say 2 sine theta is equals to 0, or you are gonna deal it with this part, 2 sine theta minus cos theta is equals to 0, right? So in this case now, what you're gonna have this one here, which is in terms of 0. So you're gonna divide by 0 there, you're gonna divide by 2, you're gonna be left with that. Then you're gonna say theta second function here 0. Then you should get an answer there. So you are gonna have theta is equals to 0 plus K360, so that you are able to find other angles as well, if you can see that, guys. Or also theta is equals to 180 plus K360, right? So therefore, in this case, guys, here on the other side, what you can do, you can take cos to that side, so you're going to be left with 2 sine theta is equals to cos theta. Therefore, you divide by cos on both sides. They like bringing this one a lot, especially in grade 12. You divide by that, so here you're going to have tan sine over cos is equals to tan, so it's equals to tan 1. So you divide by 2 both sides, divide by 2 both sides, you're going to be left with tan theta is equals to 1 over 2. So therefore, you're going to say theta is equals to tan second function 1 over 2. So with that in mind, so what do you have? You are going to be left with I already written this one. Okay, you are going to be left with 1/2 plus K 180. All right, and that's how you would deal with a question like this one, guys. If you have any question on general solution, please check our grade 11 examples on how to deal with general equation. I am Gaston Mapala. Let me see you on the next upload. We will be doing question 6 of paper 2 June exam 2024.